Okay, this is the answers or answer assistance to the popcorn activity for dual credits. So first off, make sure that you've done your pre-lab questions. And so this is just stepping through how we got that, and it's based off whatever oils we use on that day in lab. For this case, I have corn oil, and I'm showing you how I did the calculations from Fahrenheit to Celsius and then over to Kelvin, because we want to be in Kelvin when we do our gas laws. So a reminder that ideal gases have exert low pressure, no attraction, high temperature, and they don't take up much space. So a few things to go over as we go through this. For question number 2, to get the mass of the water kernel, I'm going to need the mass of the system before I start popping and the system after. And the system includes the beaker, the oil, and the kernels. And so you're going to weigh all of that, then you're going to pop them, and you're going to weigh after. The difference will be the water. To get per kernel, we will divide by the number of kernels that actually popped. Hopefully, the electronic scales will give us enough range so we can use that. If not, we'll use the triple beam balance. And reminder that since we can't use mass in the ideal gas law, we're going to convert over to moles. And so the mass, the conversion for that will be 18.02 grams per mole, because that's for water. Then to find the percentage of water in a kernel of popcorn, we're going to take the mass of water in each popcorn kernel and divide it by the mass of the popcorn kernels that popped, and then multiply by 100. Part over whole times 100. And then in order to get the volume of one popcorn kernel, you're going to use water displacement. So you'll set up your graduated cylinder, fill halfway up on a small graduated cylinder, put in 25 kernels, get the new measurement, take the difference from the initial to the final, that's my total volume displacement, and then divide by 25 kernels, and you will have what one kernel is equal to. I already mentioned that we'll need a small graduated cylinder. And the last thing to remember is that we can't use milliliters for ideal gas law, so we're going to convert over to liters, and that relationship is 1,000 milliliters to a liter. Okay, so I'm going to step you through on how to do this. Nope. There we go. So we have to know what our temperature is from pre-lab, and I'm going with the fact that I only had 23 kernels that popped. So make sure you know what your weighing paper is beforehand. We normally tar that out. So my mass is 3.71 grams. That's what I weighed on the scale. So 3.71 grams divided by 25 kernels, that equals 0.148 grams per kernel. Okay? My volume initial was 5.05. My volume final was 7.60. So 7. milliliters minus 5.05 milliliters equals 2.55 milliliters. We take the 2.55 milliliters and we divide it by 25 kernels. We get 0.102 milliliters. Since we can't use the unit milliliters, we're going to convert over. And I get 1.02 times 10 to the negative fourth liters per kernel. Moles of water. So I had 23 that popped. My initial mass was 124.89 grams. My mass final was 124.50 grams. So we do the math there. 124.89 minus 124.50. That's going to give me 0.39423 kernels because only 23 of them popped. So 0.39 grams H2O divided by 23 gives me 0.017 grams H2O per kernel. I'm going to go down here to get myself some room. Let's go ahead and get that converted over to moles. So it's 18.02 grams H2O to 1 mole of H2O. That equals 9.4 times 10 negative 4 mole per kernel. So now we're down to our calculation. So nRT, so we have pressure equals nRT over V. So we're going to have the 9.4 times 10 negative fourth mole. Let's just use atmospheres. So we're going to use 0.08206. That is a constant. Okay. Temperature was 519 because that's from your pre-lab. We're going to divide that by the volume from up above, 1.02 times 10 to the negative fourth. And when I calculate that, we'll get 390 ATM. All right. So now we're going to go back and we're going to use this number here. Okay. So that's where I'm getting that from next. So we had 0.148 grams from above, and we had right here, this is where I'm going to pull this number from too, 0.0017 grams. So to figure out how much I have per kernel, I take 0.017 grams H2O divided by 0.148 grams total times by 100, that equals 11%. Okay. The last question is on you, where you think you might have made a mistake or had an error, but that is the calculation work for the popcorn lab.